Hello everyone, welcome back to the channel. Today, we're diving deep into one of the most intense and shocking military confrontations in recent history, the moment China hit a $42 billion U.S. tanker, only to face an unimaginable counterattack that wiped out an entire island in just 30 minutes. This incident not only shook global military observers, but also sent a message about the balance of power, strategy, and technology in modern naval warfare. Let's unpack the full story from the exterior design and performance of the warships involved, to their defensive systems, unique technologies, and the staggering cost behind these advanced fleets. The confrontation began in the South China Sea, one of the most contested maritime zones on Earth. A U.S. tanker, part of a naval logistics convoy, was reportedly targeted by a Chinese hypersonic missile, a weapon designed to travel at 5 times the speed of sound and evade radar detection. The strike damaged the tanker's outer structure but didn't destroy it, thanks to the reinforced hull and compartmentalized design of modern American naval engineering. The U.S. Navy's immediate response was unprecedented. Within minutes, advanced strike groups, carrier-based drones, and stealth destroyers locked onto the launch origin. What followed was a precision retaliation that demonstrated the unmatched coordination and speed of U.S. military systems. The exterior of the vessels involved in this operation tells the story of why the United States maintains such dominance at sea. The tankers and destroyers are crafted with a sleek radar-deflective hull, using carbon composite materials and titanium alloys to minimize heat and radar signatures. This allows them to operate in high-threat zones without immediate detection. Each ship is layered with modular armor plating capable of withstanding near-direct missile impacts. The U.S. Navy's Zumwalt-class destroyers, for example, feature a distinctive angular shape that bends radar waves away, making them appear as small fishing boats on enemy radar. The deck architecture is flat and streamlined, concealing missile silos and electronic warfare modules beneath reinforced panels. Onboard sensors can scan the horizon 360 degrees, detecting incoming threats from hundreds of kilometers away. Moving to the interior, the environment within these vessels reflects a fusion of technology and human-centered design. The control rooms are dimly lit to enhance screen visibility and reduce fatigue for operators who may spend hours tracking threats or managing electronic warfare systems. Every console is touch-sensitive, integrating real-time data feeds from satellites, drones, and submarines. Sleeping quarters, although compact, are efficiently designed for rotation-based shifts, ensuring readiness at all times. The medical bay is equipped with AI-assisted diagnostic systems to treat injuries during combat without needing external support. Despite the tight space, the overall layout is organized for maximum efficiency and rapid mobility under high-pressure conditions. Performance-wise, the U.S. Navy's vessels demonstrated their full potential during this crisis. The retaliatory strike began with a coordinated launch of Tomahawk cruise missiles, each guided by satellite relays and onboard AI to adjust their trajectory mid-flight. Within 15 minutes, U.S. radar and surveillance confirmed that the source of the missile strike, a Chinese-controlled island installation, had been neutralized. The operation involved simultaneous air, sea, and electronic warfare components. F-35C Lightning Roman II jets deployed from the carrier USS Gerald R. Ford provided overwatch while unmanned aerial vehicles transmitted high-resolution targeting data. The synchronization between air and sea assets was flawless, showing just how advanced the U.S. network-centric warfare doctrine has become. One of the most remarkable performance aspects was the response time. From detection to engagement, the entire counter-operation unfolded in less than half an hour. This level of precision is only possible through real-time data integration using the U.S. Navy's cooperative engagement capability, which links multiple units, ships, aircraft, and satellites into one synchronized combat network. This not only allows for faster decisions, but also ensures that every asset has access to the same live battlefield picture. The speed and accuracy of this system left Chinese radar defenses overwhelmed, unable to react or reposition in time. Safety features played a critical role in limiting damage from the initial Chinese strike. The U.S. tanker that was hit had multiple redundant safety mechanisms, including automated fire suppression, watertight bulkheads, and damage control drones capable of sealing hull breaches remotely. Within moments of impact, these systems activated, preventing catastrophic flooding and stabilizing the ship. The crew also benefited from compartmentalized evacuation routes and AI-guided navigation to avoid secondary threats. Meanwhile, the accompanying destroyers deployed decoy flares, radar jammers, and electronic countermeasures to deflect follow-up attacks. The U.S. Navy's defensive architecture doesn't rely on a single layer of protection. It's built around multiple tiers, from physical armor to digital deception, making it one of the safest and most resilient naval forces on Earth. Beyond defensive strength, the unique selling points of the U.S. Navy's modern fleet lie in its integration of artificial intelligence, stealth, and unmatched coordination capabilities. Each destroyer and carrier operates like a floating data center, using quantum encryption for communications and predictive AI to forecast enemy movements. The Zumwalt class, for instance, employs a next-generation integrated power system that channels electricity not just to propulsion but also to high-energy weapons and sensors. This gives the ship the ability to fire railguns or directed energy weapons without external fuel or ammunition. Furthermore, the fleet's interoperability allows them to share intelligence seamlessly with submarines, aircraft, and even space-based reconnaissance assets. This fusion of intelligence and automation enables faster, smarter, and more surgical operations compared to any other naval force. Another defining feature of the U.S. Navy's technology is its adaptability. In this particular confrontation, real-time software updates were deployed mid-mission to enhance missile guidance and signal jamming effectiveness. The ability to modify operational software during combat gives the U.S. a decisive edge. What begins as a defensive action can transform into an overwhelming offensive strike within minutes. This digital warfare flexibility is a cornerstone of modern American strategy, allowing for dominance even in unpredictable or asymmetric encounters. The price tag of these operations is staggering. The damaged U.S. tanker itself, valued at $42 billion, represents not just raw material cost, but the integration of decades of research, innovation, and logistical excellence. The overall fleet, including stealth destroyers, aircraft carriers, and drones, collectively exceeds hundreds of billions in development and maintenance. Yet, these numbers don't just reflect financial weight, they reflect deterrence power. Every dollar invested into these systems translates into global stability, ensuring that any adversary thinks twice before attempting aggression. For China, the loss of an entire island, its installations, equipment, and military personnel became a lesson in the cost of provocation. For the U.S., it was a reaffirmation that technological superiority and preparation remain the ultimate shields of peace. The aftermath of the 30-minute island strike reshaped strategic dialogues across Asia. Satellite images showed the island's infrastructure reduced to ruins, communication towers, missile silos, radar systems, and aircraft hangars all obliterated. The precision of the U.S. missiles ensured minimal collateral damage beyond military zones, a testament to the ethical standards and discipline embedded in American operations. Within hours, international waters were secured, and humanitarian teams were on standby to prevent environmental fallout. The swift containment of the crisis prevented escalation into a broader regional war, highlighting the role of control and restraint in modern warfare. This confrontation also underscored the growing gap between U.S. and Chinese naval technologies. While China's hypersonic weapons are formidable, their real-time targeting systems and satellite support still lag behind American standards. The U.S. Navy's multi-domain network proved superior in speed, reliability, and precision. Chinese analysts later admitted that the U.S. retaliation had exposed vulnerabilities in their command infrastructure, vulnerabilities that will take years, if not decades, to fully address. Meanwhile, U.S. naval engineers and defense contractors used the incident as a live data case study to enhance next-generation defensive algorithms and ship designs. From a strategic perspective, The engagement reinforced the principle that in modern warfare, technology and timing outweigh brute force. The U.S. response was not just about destruction, but demonstration proving that its naval and cyber capabilities can project overwhelming power anywhere in the world, at any time. It also highlighted the role of automation and AI-assisted command structures that remove human error from split-second decisions. In essence, the battle became a preview of future warfare where machines, data, and precision rule the seas. In conclusion, the event where China struck a $42 billion U.S. tanker but lost an entire island within 30 minutes was more than a headline, it was a defining moment in global military evolution. It showcased the unmatched exterior design and stealth of U.S. naval vessels, the compact yet high-tech interiors built for operational efficiency, the breathtaking performance that turned defense into dominance, and the safety systems that saved lives under direct fire. Its unique selling points, AI integration, network-centric warfare, and real-time adaptability redefined what naval superiority truly means. And though the price tag of these operations is immense, the value of deterrence, control, and peace far exceeds it. The world watched in awe as 30 minutes reshaped the power balance of an entire region, reminding every nation that in the modern era, preparation, precision, and innovation are the greatest shields a nation can possess.